You're welcome back to my YouTube channel, Mathematics with Edu-aider. The mathematical concepts, learn them in a simplified form. Yeah. Now, today we'll be talking about forming a cone from a sector. How do we form a cone from a sector? Before now, we have treated, we know sector is a solid shape, right? And we treated them in the previous videos. But now we can have a question that will involve forming a cone out of the sector. Let's have our sector, let's have a reminder of how our sector looks like. So we have something like this. Oh, let me draw a circle. You have this, you have this, you have this. Let me draw a bigger sector. Don't forget, you take this place to the center of the circle. Then we have what? The radius. This is the radius, right? Any line drawn from the center to any part of the circumference is the radius. Then we have these two can unify. This one can equally be the radius, right? This is also the radius. So we have this place to be the radius, then that was a radii, then we have this place as theta, right? So now if you cut out this place, this is our sector. Let me call it. So sector AOB, we add it to the sector, the whole of this forming a sector. So if I draw that out, I have something like this, I have something like this, I have something like this. Assume this is my radius. This is my radius, this is my theta. Now, this is a sector drawn out of the circle, and the angle subtended by that sector is theta. Look at here already. And this place, these are the radius, giving us the radii, right? So now, how do we go? If we are given a question such that we are given a sector, and we are told now that that sector was converted into a cone, what do? We consider the properties of that sector. One, this is an arc. Can you see arc? Can you see arc AB? So what do we have? This is length of arc, right? And this is called the radius. Now, if we now have a cone form, the first question we will ask is this: how can we form a cone from this? If I fold this along this side, I fold it into each other. From this end, I fold it together. We have, this is what we're going to be having. We're going to be having this. We're going to be having something like this. And this is what we're going to be having. This is theta over here. And what is this? This is a cone. If I fold this into each other, I'm going to be having a cone. So what do we have here? Let me call this AOB. So I'm having my cone already. So what happens? As we fold this along this path into each other, what happens? This length of arc will now be the what? Will be the radius. This radius will be the length. Well, look, let's consider the properties of this first. For cone, what are the properties? It has slant height, right? It has slant height. It also has what? It has a radius. Having a perpendicular height, it has a radius, then it's slant height. Now, since you have used this to form a cone, this one I will fold along will be, this side will be this side. That means our length of arc is equal to our radius. Are you seeing that? The length and the slant height, this is the perpendicular height, the slant height of this cone will be equivalent to the radius of the sector from which it was formed. So what do we have now? We have a circular base, right? This circular base, it is equal, the properties of this circular base is equal to the what? The sector, or let me call it the perimeter of this circular base. And this one, we call this one length of arc. And length of arc is always what? Theta over 360 times 2 pi r. Why do we have the 2 pi r? It is along the circumference, right? And angle is subtended. We have this. So that means our length of arc should be equal to the what? To the circumference. So that means theta upon 360 times 2 pi. What is our length of arc? it is equal to the circumference, right? And our 2 pi r, what we are, we call this 2 pi, this is r here, this r, this is supposed to be the r. So I will call this 2 pi big R, right? So 2 pi big R here, this is what, because the radius of this circle is this. Now, this same radius is now equivalent to the length of arc, m times L, right? And that should be equal to, the circumference of this circular base is 2 pi the small r. Now, why do we have this? If we are to derive the radius of this cone that was formed from this circle, what do? Just cancel out this 2 pi. We are making r the subject of formula. So what do now? We are going to be having theta L upon 360. That should be equal to our radius. This radius is generated already. What if you are to get the theta? The angle that was subtended and is now the angle of the cone. What do we have? We are going to be having a theta. You can do that from here. Theta is what? From here. If you multiply both sides by 360, so theta should be equal to 360 r divided by L, the slant r. Or what we call the slant, the slant r. Are we good to go? Now, having gotten this, we can equally generate something else. Look at this quickly before I end this video. If I have this now, what if you are going to calculate the height of this cone? What do we have here? This is the height. We don't have the height, we have the slant height, we have the radius. So we can go from here, drawing out, that's what we have, a right angle triangle, isn't it? And what do we call this type of cone? It's a right angle base cone. So we have this, we have this, we have this, we have this in right angle, we have our h here, we have our l here, we have our what, our radius here. We are looking at a formula that will get us h, which is the height. So what do we have? Our h squared, obeying the law of Pythagoras theorem. That theorem, we are going to be having L squared to be equal to what? H squared plus R squared, right? So our H squared can now be equal to L squared minus R squared, such that H squared can now be equal to what? L squared. Let me write this. Recall, R is equal to our radius, theta L upon 360, right? That's what our radius is. So recall that into this place. You get? So our h squared can now be equal to what? We are having L squared minus theta L upon 360, right? This one all squared, right? So our h, now the height can now be equal to L squared minus this 360 all squared. Then you take the square root of everything. So you have this. This is what our height now, because it's a positive value, height. So I don't need to include this, it should be positive. Can we get that? In the next video, we'll take an example on this. Thank you for staying with me. Remain blessed.